Now we have to do the test for nitrite anion, right? Again, nitrite anion is a radical which will give a preliminary test with your dilute HCl and dilute H2SO4. Now in this preliminary test, what will happen? We'll take again a pinch of salt and we'll put dilute HCl inside it, or dilute H2SO4. Now what will happen? Nitrite anion, when it is reacting with H plus, right? If it is in the cold condition, initially it might be possible that a pale blue liquid is formed because of N2O3. Then this N2O3 is an anhydride of HNO2 and water is there. You know that N2O3 will lead to the formation of HNO2, nitrous acid. After that, this nitrous acid will undergo disproportionation reaction because it is in the intermediate oxidation state to form the highest oxidation state HNO3 and nitric oxide. Now nitric oxide is having a free radical but it is colorless gas. Now what will happen when this nitric oxide gas is just coming out from the container near the mouth of the container? This nitric oxide reacts with oxygen gas and it leads to the formation of brown color NO2. Understood that? Now it means that inside this region you never see a brown color, but near the mouth of the container, suddenly a brown color will be visible, which will be indicating that I am having NO2 gas coming out of it. Now, if NO2 gas is coming out of it, it might contain nitrite ion. So this is a preliminary test for nitrite anion. Right? Now, in order to have this NO2 gas is coming out, right? What I'll do, I'll pass this NO2 gas into a Ki starch paper. Now this is a paper which contains Ki and starch, potassium iodide and starch. Understood? Now what will happen? This NO2 is an oxidizing agent, will oxidize I minus to iodine. And iodine, you know that in the presence of starch color, the starch will produce an inclusion compound which is blue-black in color. Now, this test is a confirmatory test for nitrite anion, right? Now, again, what will happen? We'll be doing the further confirmatory test for nitrite anion. Now, the very important confirmatory test which we have to do over here is like brown ring test that we'll do in the upcoming part. Now, first silver nitrate test, AgNO2. Now, you add silver nitrate inside the nitrite solution, you will come to know that it will combine with nitrite to produce AgNO2, which is nothing but a white PPT. So I'll get a white precipitate of silver nitrite, again a confirmatory test for AgNO3. Now I have a brown ring test, right? Now what exactly happened in brown ring test, we'll study right now. It's a very important test in the perspective of JEE and advanced. Okay, now in brown ring test, which is the confirmatory test for nitrite ion, what you'll do, take a test tube. Inside this test tube, you have a solution of nitrite anion. You do one thing, add acetic acid inside this. So I have added acetic acid solution inside it. Okay. What exactly will happen? This acetic acid will react with nitrite anion. It leads to the formation of HNO2, right? Instead of acetic acid, we can use dilute H2SO4 also. Now HNO2, when I'm forming HNO2, it decomposes again to form nitric oxide. Now very well said that from, like from the sides of it, to do one thing, take a glass rod. This glass rod is there, the pour FeSO4 solution in it. Put it very slowly. Now FeSO4 will go slowly inside the solution and will go and mix in the solution in the periphery where at the junction, wherever these solutions are meeting, no, at this particular junction we will be having a brown color ring, and that is what is known as brown ring test. So I have a brown ring color over here, right? Now how this color forms, this FeSO4, that is Fe2 plus ion, will form a complex with water molecule and NO. There will be 5 water molecule involved over there, which leads to the formation of a brown ring. And this is the complex which will be getting over there. The net charge will be 2 plus, and very important thing, Here, NO will donate a pair of electron to iron. From plus 2 oxidation state, it will be converting into plus 1 and NO will convert into NO plus 1. Now it is nitrosonium oxide and due to this electron transfer, this iron is gaining brown color. Understood that point? It might be asked as a very important point in your examination, as a very important thing. So the brown color precipitate which is forming over the periphery wherever the solution is meeting, and it will give a very nice brown ring whenever at the junction of the solution, right? So I guess you understood the brown ring test, correct? Now we have a test for acetate anion, right? Now what exactly acetate anion will do? So I'll test for acetate anion. Now preliminary test require again a salt. You do one thing, add salt and add some drops of dilute H2SO4. Now what exactly happened? This acetate will react with H plus and it leads to the formation of a gas which just comes out and it is the smell of vinegar. Obviously vinegar is acetic acid, so you'll have a vinegar type smell, right? Now another thing, what I'll do, the confirmatory test for acetate which is very important is like I'll add FeCl3 inside acetate solution. Now it is very important test and don't read this part, right? Whatever I am writing over there, just copy that because that is important. Now they have already formed the brown color, okay? But actually what happens, just listen. Now 3 ion of Fe3 plus will combine with 6 acetate molecule plus 2 OH minus. It results in the formation of Fe3 C3 CH3COO minus whole 6 OH whole square, net charge plus 1. It is red blood color. This red blood color when it forms like Fe3 CH3CO whole 6 OH minus, that is whole square, the net charge obviously becomes plus 1. When you just heat it or just keep it for a longer amount of time, that red blood color instantly decomposes to form FeCH3COO in an OH whole twice. Either this might be given to you or FeCH3COO whole thrice, which is this molecule, is given to you. Both are correct, right? Now both will form brown PPT. So reddish brown PPT you will be getting, right? Rather I'll write reddish brown PPT. Now understood that I'll be getting a reddish brown precipitate with acetate. So this is a confirmatory test for acetate, right? Now what we'll do, the test for thiosulfate. Okay. Now the test for thiosulfate, correct? Now again preliminary test for thiosulfate is, I'll take a YouTube in this container, in this particular thing. So this is a test tube with a particular YouTube where you can fill a particular solution inside it. Taken. Now what I'm doing over here, I'll just put that pour dilute H2SO4. Now what exactly happened? Thiosulfate, when it reacts with your dilute H2SO4, it instantly decomposes and it's unstable in acidic medium. Just remember that whenever you have to form thiosulfate, no, then sulfur dioxide plus sulfide in basic medium combine together to form thiosulfate. But in acidic medium, the reverse reaction takes place in which it decomposes to form sulfur, which is nothing but a colloidal white turbid solution. White colloidal turbidity will be there, and simultaneously sulfur dioxide gas escapes out. Now understand that this has a burning sulfur type smell, you know that, and you cover the lid and just pass this SO2 in with K2Cr2O7 solution. You know that K2Cr2O7 will reduce to form Cr3 plus and sulfur dioxide will get oxidized to form sulfate anion. Now obviously I'll get a green color and from orange color. So it'll give me a confirmation of sulfur dioxide gas which is over there. So it's a very important test. You should remember that. Then another thing, this is the this is a preliminary test by which you can say that thiosulfate might be there. Now, what about confirmatory test? In confirmatory test, what you will do, you will add first iodine solution. You know that thiosulfate will react with iodine, which is like having a bluish violet color. Now, obviously, thiosulfate will get oxidized to tetrathionate ion and iodine get reduced to I minus. The blue color of iodine, the intensity of that color decreases, which confirms the presence of thiosulfate ion in it. After that, you have a barium chloride solution test. In barium chloride, what will happen? Barium 2 plus ion will react with your thiosulfate, and I'll be getting a precipitate of barium thiosulfate. If this reaction doesn't happen with calcium, remember that calcium solubility product is very high with respect to that. So I'll be getting a white PPT only with your barium chloride, right? Now, the test which we are doing for thiosulfate is very important, and these two tests are actually asked multiple times, and it has a link with the P as well as D block elements. For example, the test is silver nitrate test. Suppose if I'm adding silver nitrate inside the thiosulfate solution, what exactly happens? First, Ag plus will react with thiosulfate, and I'll be getting a white PPT of Ag2 H2O3. So I'll be getting a white PPT here, which on further addition of thiosulfate will form a soluble complex which is used in developing of films in photography also. I'm just giving an extra information over here so that you should remember that properly. It'll become soluble. No, sorry, not 3 plus, it'll be 3 minus. It'll be soluble. Now understand that on standing the solution, this complex will, or on heating, this complex will undergo dissociation to form Ag2S, which is black in color. So I guess you understand what is the nature of reaction of AgNO3. If you put Ag plus in limited amount or an excess, doesn't matter. Put Ag plus, I'll be getting white PPT, and put extra thiosulfate. What will happen? It'll get dissolved to form a complex. And after it getting dissolved to form a complex, either you keep it like that or you heat it. I'll be getting Ag2S, or you add extra AgNO3. I'll be getting Ag2S over there. Now, after that, you have a test with lead acetate. Understand that I'm adding lead acetate solution. Okay. Now with lead acetate, I'll be getting a similar reaction in which lead 2 plus cation will react with thiosulfate anion to produce initially a white PPT of PbS2O3 is white PPT. Now this white PPT on heating or on keeping on standing the solution again become PbS, which is black PPT. I guess you understood the nature of the reaction of with AgNO3 and like Pb lead acetate is almost similar except of the complex formation thing over there, right? Okay. Now, guys, we'll be studying about class 2A anions, right? We very well know that class 2 anions are those anions which will give preliminary test. Either they will evolve gas as a prelim test, or they will produce a color gas as a prelim test with only concentrated H2SO4 along with heating, right? Now, these are the things, these are the ions which actually gives, what are the class 2 ions here? Like probably like F minus, Cl minus, Br minus, I minus is all the halides over there, nitrates and oxalates. So these are the anions we'll be testing with the help of concentrated H2SO4. So we'll be taking these ions one by one. First we'll do prelim test, which will indicate that F minus might be there or any of these anion might be there. And after that we have to do confirmatory test, which confirms the presence of these ions. Now understand F minus, right? What we'll do, we will pour F minus. I'll take a salt. F minus, again a pinch of salt. Again, prelim test will be done with the salt only. And put few drops of concentrated H2SO4 and heat it. When you heat it, no, I'll be getting HF. And you know that HF is highly corrosive. Highly corrosive. Right? Very reactive gas. Now understand one thing, what exactly happens. When this gas is coming out, no, take a needle, right, and scratch this side of the test tube. When you scratch this side of the test tube, no, what exactly happens? Silica get exposed for the reaction. Now what exactly happens? SiO2, when it get exposed in this particular edges where the places you have scratched the glass, what will happen? SiO2 will react with HF, and I'll be getting the vapors of SiF4. Now understand that the vapors which are coming out over here are the colorless vapors of SiF4. Now understand, near the mouth of the test tube where the SiF4 fumes are coming out, right? So these are the fumes of SiF4. What you will do? Take a glass rod which is moistened with water. So I have water over there, right? Now what exactly happen? SiF4, when undergo hydrolysis with water, I'll be getting H2SiF6, which is an acid, hydrofluorosilicic acid, plus I'll be getting SiOH whole 4. Now this is soluble and this has a white waxy texture. So I have a white waxy solid. By the touching the glass rod, you will feel the white solid is there on the glass, right? So with this white waxy solid, you will come to know that okay, fluoride is available here. Now understand, one more confirmatory test is there with calcium chloride. Put calcium chloride solution inside it. The fluoride will react to form calcium fluoride, which is a white PPT. So this is all for the test for F minus, right? And F minus test, they are not asking, but yeah, there are certain things which you should know. HF is corrosive gas. And yeah, on etching the glass, like it used to etch the glass. You know, the in glasses, there are certain times when you see the names are written over the glass, right? Where the glass is missing in that thing. So the name is getting embedded inside the glass. It is done with the help of HF because HF is highly corrosive, right? It eat away the glass wherever it is reacting it with, right? Now there's a test for chloride anion. Now what exactly happened? This chloride anion, when I'm adding concentrated H2SO4 along with heating, what exactly happened? I'll be getting HCl fumes. Right now, HCl fumes are very pungent smell. This is colorless, pungent gas. Now understand one thing exactly what happens here. Now there's a lot of things going on here. Take care. Now you have added Cl minus salt. You have taken prelim test. You are doing right. In this salt, what you did? You added concentrated H2SO4 inside it. Right. Once you added concentrated H2SO4, you will find out this HCl gas is coming out. Right. Now do one thing. This HCl gas, what will do? There are two things to how to predict the HCl gas is there or not. Now, in first thing, take a glass rod dipped in ammonia solution. So I do have ammonia solution dipped over the glass rod. The glass rod dipped in the ammonia solution. Now, what exactly happened when ammonia HCl comes in contact with this ammonia, right? It'll produce white fumes of NH4Cl. So you'll find out from the glass rod. No, suppose this is a glass rod. The white fumes are coming out of it. They are forming over there. You'll come to know that okay, I do have HCl gas which is coming out of it. Okay. One more thing, this HCl is acidic in nature, which turns your blue litmus into red. blue to red, litmus. Getting it? Simple, right? Now, next test is you do one thing. Again, take Cl minus and just put some MnO2 also. So I do have Cl minus and MnO2 here. Now again, put concentrated H2SO4 here. If I'm putting concentrated H2SO4 and heat it, I know that HCl gas is coming out, which will further get oxidized by MnO2 to produce Cl2 gas, which is greenish yellow gas. Got it? Now, these are some tests which you have to do for chloride. Now, there are more tests which are very important for chloride, and chloride anion is very important if I'm talking perspective of JEE. Now, a lot of question comes in chloride, right? And they'll be asking you basically the test exactly what is going on. Now, we do have a silver nitrate test. Now, whatever I'm telling you here, write everything properly because I'm telling you something extra which is not given over there also. Okay. Now I do have AgNO3. Now this AgNO3, Ag silver nitrate when it reacts with the Cl minus, right? Now it leads to the formation of AgCl, which is a YPPT. The very same AgNO3 gives a test with Br minus as well as I minus. With Br minus, the same thing will come out as AgBr, and which is again a precipitate. I have AgI, which is again a precipitate. Fluoride never give precipitate with Ag plus. It's a strong electrolyte. AgF is a strong electrolyte. They are having very less solubility. That is why they are precipitating or they are weak electrolytes. Okay. Now this is pale blue or pale yellow, and that is LOPPT. Now understand that what is it? How to differentiate between these precipitate? Do you know what? If I take AgCl and keep AgCl inside this ammonia solution, ammonia in water is known as ammonium hydroxide. Keep in ammonium hydroxide, you know what? AgCl gets soluble due to the formation of this complex. You know that the coordination number of silver is 2. So I'll be getting a complex which will be soluble over there. And this same reaction happens with AgBr, but it is sparingly soluble. The ammonium hydroxide doesn't make full AgBr to get dissolved in it. So some it is what not completely soluble. Some of the AgBr becomes gets soluble. So it is like sparingly soluble in ammonia. Partially soluble in ammonia. If you do the same thing with AgI, right? AgI, if you put that thing ammonium hydroxide, it'll never get soluble. It'll never get dissolved because AgI is highly stable. Its KSP is very, 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 very low. So I'm not getting any Ag plus ion inside the solution to react with ammonia gas or ammonium ion. Now, this is the main thing. Now, in D block element, they're asking the same thing. Like, I can have AgCl or AgBr, AgI. These three, if I'm just reacting it with KCN solution, that is KCN, or I'm reacting it with thiosulfate, all of them are soluble. All of them are soluble fully to form a complex AgCN whole twice minus and coordination number is 2. Similarly, Ag H2O3 whole twice, overall charge 3 minus. Again, it is soluble. So both the anions are dissolved. All this AgCl, AgBr, AgI is soluble in Kc and H2O3, but their solubility differs only in ammonia solution. I guess you will come to know the differentiation between the AgCl part, AgBr part, and AgI part is very important, right? Now we'll again continue with the chloride test. We come to know that AgNO3 with Cl minus produces a white PPT which is readily soluble in ammonia water or ammonia solution, right? Now, the very important test over here is chromyl chloride. We'll be doing after the lead acetate solution test. Now understand that I do have Cl minus. This Cl minus will react with lead acetate right? And it leads to the formation of PbCl2, which is a precipitate, which precipitate white precipitate. In many of the lab experiments, sometimes you'll never get this PbCl2 precipitate because this PbCl2 precipitate is soluble in hot water. It is soluble in hot water and become precipitate in cold water. Understood? And after that, you do have a chromyl chloride test. Okay. Now, what exactly is there in chromyl chloride test? I'll do one thing. I'll take a test tube with a U-tube in it. So this is a test tube which contain or which has a U-tube inside it. Okay. Now what I did here, added salt. Make a solution, chloride solution, not salt. Make a chloride solution. Okay. So I have a solution of chloride. Put concentrated H2SO4 and K2Cr2O7 and heat it nicely. Just give a nice heat to it. You know what? I'll get the reddish orange vapors of CrO2 Cl2. Why I'm saying vapors? Because chromyl chloride is CrO2 Cl2, which will be forming over there. It is a volatile liquid. Someone has asked, what is the nature of CrO2 Cl2? Whether it is gas or it is a liquid, is actually a liquid which vaporizes instantly. Getting it? Now listen, where we chromyl chloride test. In chromyl chloride test, what exactly happens step by step? First, chloride anion react with concentrated H2SO4 to produce HCl gas. HCl is there, right, in the solution. Similarly, K2Cr2O7 first react with H plus and form chromic acid, H2Cr2O7. All of us knows that H2SO4 is a dehydrating agent. It'll remove H2O from Cr2O7, so I'll be getting two molecules of CrO3. Okay. Now these two molecules of CrO3, when it combines with HCl, which is produced in the above reaction here, H2O will lose H2O and I'll be getting CrO2 Cl2. That is a chromyl chloride thing, which is reddish yellow vapors, reddish orange vapors. Okay, which is coming out of it, out of the test tube. So here I am getting the vapors of CrO2 Cl2. This one is chromyl chloride. Do one thing, put NaOH inside it. What I have added here, NaOH, या फिर sodium carbonate or your wish. Just close this lid. This CrO2 Cl2 will pass through it. You know what? When CrO2 Cl2 will react with NaOH, it leads to the formation of Na2 CrO4, which is yellow in nature. And after that, also you can add lead acetate inside it. If you add lead acetate, no, sodium chromate reacts with lead acetate, right? Now, what exactly happened? I just write it over there. Sodium chromate, when it reacts with lead acetate, it leads to the formation of lead chromate, PbCrO4, which is again a yellow PPT. Understood? Now, I'm telling you one more time. If you added H plus here, if you added OH minus here, this precipitate will get dissolved because chromate in acidic medium becomes dichromate and lead dichromate is not at all a precipitate. With OH minus, first will form a precipitate of PbOH whole twice, and with OH minus, what happens? Uh, Lead hydroxide is an amphoteric in nature, will readily get dissolved to form PbOH whole 4 2 minus complex. So this compound or this complex is soluble in excess of acid, in presence of acidic medium and presence of excess of base. So I guess this is all about chloride. Take care is a very important topic, and especially this chloride chromide test. And I have elaborated all the side reactions also which might take place over there. and in generally comprehension forms or in multiple correct form, this kind of test is covered with these kind of detail. Okay, make sure that you write each and every reaction properly. You should know the logic, what is going on, and exactly what is producing with what color, right? So this is very important. We'll move ahead with the test of bromide now. Okay, now test for bromide anion, right? Again, the preliminary test, you know that in prelim test, what exactly you do, you will use a salt rather than salt solution. You'll take a salt, add concentrated H2SO4, heat it nicely. Getting it? Now there is a difference in the reaction which we have observed with HCl as well as HBr over here. Now, what exactly happens? Concentrated H2SO4, we know that is an oxidizing agent. A very like concentrated H2SO4 is an oxidizing agent. Okay. Dilute H2SO4 is not at all an oxidizing agent. Now understand one thing: H2SO4 is not capable to oxidize HCl to Cl2, but when Br minus or I minus, I'm repeating again, Br minus and I minus is reacting with H plus ion, this will produce HBr and this will produce HI. Now understand one thing. Both HBr and HI can be easily oxidized by concentrated H2SO4 to respective halogens. So I'll get Br2 and I'll be getting iodine. And here Br2 is nothing but reddish brown gas. You see over there. And is clearly a redox reaction because plus sulfur from +6 oxidation state is changing from +4 oxidation state. Getting it? Now, and again, you do one thing in the very same container. If you put MnO2 also, crystal. So MnO2 is also an oxidizing agent, will further oxidize HBr in large amount to Br2, MnO2, right? Again, that color intensify. Whatever reddish brown color you are getting, no, it get intensified, isn't it? Because extra reaction is taking place, so reddish brown or color will intensify. Reddish brown color intensify. Okay. Now listen. If you understood all this stuff, it'll get intensify, it'll become large in amount. Okay. Color intensity increases. Now for now silver nitrate test. Again the same thing. What exactly happened with the silver nitrate? I already told you that I'll be getting a pale yellow precipitate of AgBr. Now this AgBr is not completely soluble in ammonia. It is like partially soluble. With KCN with hypo, it is completely soluble. Right? The same thing is given over there, which we have done earlier. Now lead acetate. Now again the very same reaction which is given by chloride, right? Then this lead acetate solution will be giving. I'll be getting a white precipitate of PbBr2. This white precipitate is soluble in hot boiling water. Getting it? And chlorine water. This is fun. It is fun. This test is fun. What exactly happened over here? Take bromide solution. So I do have a solution of bromide. Put chlorine water. Chlorine dissolved in water. Put chlorine water. We know that chlorine water is also HOCl. It reacts to give HOCl, which is an oxidizing agent. Right? Or chlorine itself is an oxidizing agent which can oxidize Br minus to Br2 because it is more electronegative than bromine. So chlorine have a tendency to accept electron. Bromide will lose electron to form bromine. And above that, what we have, I have a layer of chloroform or CS2, whatever organic solvent you want to take. So I can take CHCl3, I can take CCl4, I can take CS2. What happened? This reddish brown precipitate, this reddish brown gas will evolve due to oxidation, and this reddish brown gas is readily soluble in this organic layer. So this produces a yellowish orange color, not very, it is not brownish orange, it's yellowish orange color in that particular layer. So I'll be getting yellowish orange color for iodine. If I'm doing the same reaction with I minus, I'll be getting a bluish color inside the layer. So you'll come to know that if the organic layer becomes yellow orange, that means this layer is actually uh, make bromine gas to get soluble inside it. And because of that, it becomes yellow, orangish, yellowish color. Okay. This is the test with chlorine water. After that, again, potassium dichromate. This is just written for the sake of writing over there. If concentrated H2SO4 is actually oxidizing the HBr into Br2, I'm adding potassium dichromate. I'll not be getting any chromyl chloride type stuff. Chromyl bromide will not form. Take care. Rather, potassium dichromate will oxidize KBr to Br2, and we know that Br2 is having this yellowish, orangish brown color, right? So brownish orange color gas comes out. So I guess you understood the solution, this particular test for potassium dichromate, right? So we'll be starting with the test of iodide right now. It will be similar as halide only, and most of the reaction of I minus we already covered, right? Okay. Okay. Now iodide anion test. What you will do again, I minus with concentrated H2SO4 will produce iodine, which is bluish violet vapors which will come out, right? Fine. Now this we have already done that, similar as Br2, I minus will get oxidized by concentrated H2SO4 to form iodine, right? Now you have silver nitrate test. Again, we have done that. AgI will be like a dark yellow precipitate. It will be like having a curdy texture. So it'll be like curdy precipitate of silver iodide will be formed. And it is slightly soluble in concentrated ammonia. That means like negligible soluble is not all soluble. Make it like that. Take it. Lead acetate solution. Now understand that this lead with I minus leads the formation of PbI2, which is a yellow PPT, right? If it is a yellow PPT, understand that again on heating the solution, it will become soluble. If you cool it, you will be getting a layer of PbI2, which is start forming over the water. Looks very beautiful. Okay. After this, you have potassium dichromate test. You know that I minus will get oxidized by Cr2O7 to form I2, which is violet color, plus Cr3 plus green color solution will be formed over there. Chlorine water, same thing. We have already discussed that iodine gas will liberate, and in the chloroform layer or CS2 layer or CCl4 layer, it will be like having a blue or violet color. Getting it? Now, copper sulfate solution. It is very nice reaction. Okay, there is some error given in this literature here, so I'll just make it correct. Now it gives a brown precipitate. Doesn't give a brown precipitate. Rather, it gives a brown color solution. You know what we are actually doing? This copper 2 plus ion, I'll put in excess of Ki. We know that copper will get reduced to form CuI, which is nothing but a white PPT. And I'll be getting iodine gas because I minus get oxidized to I2, Cu plus is getting reduced to Cu. It's a very standard reaction. I2 in presence of Ki, that is yellowish brown color. Okay, like brown color solution. And this color, brown color, is due to this formation of Ki3. Just remember that. And you know what? If you put hypo, Ki3 reacts with hypo, the hypo get oxidized to tetrathionate, and it get reduced to form this I minus again. So the brown color become fades away, so it will become a clear solution, right? So I'll be getting a clear solution. Now with mercury, right? Mercury chloride solution. Now with HgI2, what exactly happened? With HgCl2, it'll react with I minus to form HgI2, which is scarlet red PPT. This scarlet red PPT is in excess of Ki, will form a soluble complex. So first I'll get a precipitate, and this reaction is very, very, very important. Just note the point. This reaction is very important because it is used to estimate the amount of Cu2 plus in the titration method. This reaction, you have seen it many times in the redox reaction questions. Okay. So it is not like very difficult for you to remember these things, right? So now what we'll do, we'll be studying nitrate. Okay. So we'll start with the nitrate now. So hopefully you have written that thing and write down every reaction and every logic properly. Okay. I just told you that this chapter will give you a full revision of very important reaction of P block and D block also. So pay maximum attention to this particular chapter. Now I do have a nitrate ion test. Now what exactly happened? Nitrate ion, again you take a salt. In that salt put concentrated H2SO4. Just add some amount of H2SO4 in it. Now when you're adding some amount of H2SO4 inside it, again this NO2 minus will NO3 minus will react with HNO H2SO4, right? Now what exactly happened? This reacts to form NO2 gas, and on heating this HNO3 gas will form and it will get decomposed to form NO2 gas and oxygen gas. Now understand that NO2 is actually brown color gas. This gas is different from bromine gas because in bromine there is a reddish tinge inside the brown vapors. So it is completely brown color gas, right? Now, again, I do have a brown ring test over there, which we have done in nitrite also. But the main difference over here is instead of acetic acid, which we have used in nitrite anion, we'll be using concentrated H2SO4 for the preparation of this brown ring here. Take care. It's very important. Again, it's very important. And these grounding questions asked now and then in the competitive examination. Okay. So now when a freshly prepared solution of Fe2 plus again FeSO4 is there, is added to nitrate solution and concentrated H2SO4 is poured slowly. Now understand that in the last brown ring test, I have actually poured FeSO4 from the sides of the what is that? I've taken no that thing glass rod, right? In that glass rod, I was pouring FeSO4. Here, I'm not pouring FeSO4. Rather, I'm adding concentrated H2SO4 slowly, and because of that, I'll be having these stuff. Now, understand what exactly going on here. I do require large amount of acidic medium for this brown ring to form. This will not produce by dilute acetic acid or dilute H2SO4. I have to add concentrated H2SO4. Now what exactly happened here? I'll be having a solution of FeSO4, which is already there, and I'll be having a nitrate anion. Now, with the help of this glass rod, right? This is a glass rod. Take H2SO4 in a dropper and put H2SO4 slowly so that it'll go here, it'll mix over here, and again at the junction, a brown ring formation takes place. Again, the brown ring formula will be same as the brown ring which is produced with nitrite thing. And exactly what happened over here, that the nitrate anion in the presence of acidic medium will become HNO3. Okay, after getting HNO3, if I'm having ferrous sulfate, right? The ferrous ion will get oxidized by this HNO3 to form Fe3 plus ion and nitric oxide. Now this is the reason I'm getting a nitric oxide gas, because some of the Fe2 plus is getting oxidized to Fe3 plus. So nitrogen is losing its oxidation state from +5 to +2. Now this NO gas, you know that in the presence of I'm having FeSO4 in excess. The remaining Fe2 plus will react with this NO in the presence of 5 water molecule, and this complex will be produced over there, and that complex is FeH2O whole 5 NO. Overall charge obviously +2. We have discussed it already that there is the odd electron transfer takes place from this NO to this ion, and the ion oxidation state is +1 over here, and because of this electron transfer, it will have a brown color, right? Okay. Now we'll be doing class B test. No, maybe like oxalate is pending. We'll be after oxalate, we'll be doing class test. Class class B anion test. Right. Okay, now we do have a test for oxalate. There's a last anion in the category of class 2A, which gives a prelim test with concentrated H2SO4. Again, you do have an oxalate anion. Prelim test will be done by concentrated H2SO4. Now understand that this is an oxalate ion. On heating, it will become oxalic acid with H plus. We know that on heating oxalic acid, it gives H2O. I'll be having carbon monoxide. I'll be having carbon dioxide. So I'll be having brisk effervescence. So I'll be having brisk effervescence, and you can test the presence of CO2 by passing CO2 from the YouTube to calcium hydroxide is lime water or barita water. I guess you understood that point. Okay. You can do that. And you have already done the side reactions in the YouTube for this carbon dioxide. Okay. Now exactly what you have to do here. I got this brisk effervescence, though it might be present over there. Now the second test is silver nitrate test. Now Ag plus, when it does react with your oxalate solution, it leads to the formation of Ag2C2O4, which is a white precipitate. Interesting fact about this white precipitate: this is soluble in your ammonia, as well as this is soluble in your this ammonia, what ammonia solution, ammonium hydroxide. So whenever it is like ammonia is given to you, ammonium hydroxide is given to you, one of the same thing. So don't get panic, right? Now, or it is also soluble in your HNO3 solution, dilute HNO3 solution. What exactly happened here? With ammonia, all of us knows that we have already formed a complex of Ag plus. With ammonia, which is like a soluble complex, will get dissolved. Dilute HNO3 will oxidize oxalate to carbon dioxide. So present it is not present, and nitrates are soluble. So I'll be getting AgNO3 back. So again, it is soluble. So I get you understood the fact behind this oxalate thing and this Ag2C2O4 thing. Okay. Now understand with calcium chloride. In calcium chloride, this oxalate will lead to the formation of your calcium oxalate, which is a white PPT again. A fun fact about it: in acidic medium, dilute HCl, it is soluble, and in CH3COH, acetic acid, go to hell, it is insoluble. Understood? So it will not get soluble in that. Now, next is potassium permanganate. That thing you have done in your labs many times, and this is the standard experiment your 11th and 12th class lab curriculum is covering. That manganate, which is like purple pink in color, when you react it with oxalate in the presence of acidic medium, this permanganate is there. Permanganate will oxidize oxalate to carbon dioxide, and it still get reduced to Mn2 plus in the presence of acidic medium. Okay. Now understand that Mn2 plus appear to be colorless, but it is actually a buff color, which we know is skin pink color. If in your D block element, they are asking you which of the cation is colorless, and in there Mn2 plus is written over there. Please, for God's sake, don't mark it as colorless as you have observed it as colorless in your lab, because it appear to be colorless. It is not colorless. It is skin pink color. It'll be like this skin pink. So buff color we used to say for M2 plus. Getting it? We'll move ahead now. Okay. Now we'll be doing the test of class B radicals, like which involve redox reaction or which involve this precipitation reaction. The sulfate, borate is there, magnate, and this chromate is there. Right? We'll do that. Now we have to do a test for class B anion radical or acid radical. The two acid radicals over there is sulfate and phosphate, and another two is which require redox reaction to actually find them out. That is like chromate, dichromate, permanganate, right? Now first we'll start with your sulfate. Now there are very nice things given over there regarding sulfate, that all the sulfate except that of barium, lead, and strontium are water soluble, right? These are precipitate, and calcium also, yeah. Some sulfate of calcium are and mercury too are slightly soluble. That means they will become precipitate eventually, but yeah, they require large amount of concentration to become precipitate, right? Comparatively again. Now the test for these sulfate is like I have barium chloride solution. This barium chloride will react this BaCl2 is colorless solution. Add sulfate, I'll be getting a white precipitate of BaSO4. Now this BaSO4 is not soluble in dilute HCl or dilute HNO3, insoluble. That means no further reaction is taking place. Now mercury 2 nitrate is soluble. See, the thing is, mercury gives a very important reaction with sulfate. It actually forms basic mercuric sulfate, which is 2HgO dot HgSO4, which is yellow BPT. It's a very important reaction, very important reaction. And most of the people will ask you this mercury case, this basic mercury sulfate. Now, after this, for sulfate, you have lead acetate. Again, I'll get a white BPT of your lead sulfate. And lead sulfate is soluble in hot concentrated sulfuric acid. It gets further soluble in hot concentrated sulfuric acid. Is a white PPT. We have done all this lead sulfate wala reaction already. Okay. Now for phosphate, you have silver nitrate. I'll be getting a yellow precipitate of silver phosphate, Ag3PO4. Now barium hydrogen phosphate solution with barium, add barium chloride or add barium chloride, the phosphate will react with it to form a white precipitate of barium hydrogen phosphate, and it is for that in the presence of dilute ammonia, like ammonia gas. What will do? Ammonia solution will extract H plus. I'll be getting a white precipitate of barium phosphate after that. So first I'm getting a white precipitate of barium hydrogen phosphate, which is like more soluble as compared to barium phosphate, which will be produced when you will react with ammonia, because ammonia will extract this H plus and I'll be getting phosphate anion fully. Getting it? So barium phosphate I'll be getting, which is a white PPT. Magnesium nitrate reagent or इसको magnesium mixture भी बोलते हैं, it is also known as magnesium mixture. Now, what exactly happened? Hydrogen phosphate, magnesium, magnesium ion, ammonia. I'll be getting magnesium ammonium phosphate, which is again a white PPT. And this mixture is known as magnesium mixture, right? It will be used in qualitative analysis of cations, right? Now, ammonium molybdenate, now phosphate. This is the test which is very important for phosphate. What exactly you do? You react phosphate with ammonium molybdenate, ammonium molybdenate, MOO4. There'll be like 12 molecules of this will be reacting with it. I'll be getting ammonium phosphomolybdate. So ammonium phosphate, write down ammonium phosphate dot 12 MOO3 molybdenum oxide MOO3. And you know what? The color of this precipitate is canary yellow. It's a very nice color to see. Take care. Hopefully you would have performed this reaction in the lab, then you will come to know, okay, this color is actually looks very nice. Okay, canary yellow. This one is phosphoammonium molybdate, and this is the formula. I guess this is the formula given over there already. Okay, but ammonium molybdate formula is incorrectly given. It is like ammonium molybdate. You have ammonia whole twice molybdate, right? Now after that you have iron 3 chloride solution. It gives a yellowish white precipitate of iron 2 phosphate soluble in dilute mineral acid. To add this thing, I'll be getting iron phosphate, which is nothing but yellowish white precipitate. It will be a yellow white precipitate and it is insoluble in dilute acetic acid, but soluble in mineral acids. Then, for example, take HCl. It is soluble in HCl. Getting it? Yeah, but the phosphate important reaction is the ammonium molybdate one is very important. Repeating it again. It's very important. Okay, we'll move ahead now. The reaction of chromate and dichromate. Okay. Now these are the reactions which require redox reactions. Okay. Now, now in this, what exactly happen? I have chromate and dichromate test first. Okay. Now all these reactions you would have already done in your D block element. I'm just giving a brief discussion about it. We know that chromate and dichromate exist in equilibrium with each other in the presence of acid and base. What exactly happen in acidic condition? This chromate ion in acidic medium will remain in equilibrium with dichromate Cr2O72 minus plus H2O. Understand one more thing. If the H plus concentration is large, I'll be getting dichromate. If OH minus concentration is large, H plus decreases. So according to Le principle, the reaction goes backward. This chromate is yellow in color and this dichromate is orange in color. Orange, right? Now understand one thing here is already given there. Now what we'll do, we'll be studying this confirmatory test for chromate and chromate first. Now barium chloride, right? Barium chloride when we react with chromate, I'll be getting barium chromate, which is nothing but a white precipitate. So understand here, barium chloride solution, right? So what will happen, I'll be getting a pale yellow precipitate of barium chromate. Chromate is yellow in color, Ba2 plus is colorless, that is pale yellow precipitate. Now again, this precipitate is insoluble in acidic medium. Why? Because in acidic medium, I'll be getting chromate converted into dichromate. When it is converting into Cr2O72 minus, so Cr2O7 cannot 2 minus cannot form a strong lattice with barium, so it is not a precipitate. It's not at all a precipitate. Rather, if you add more barium in the presence of basic medium, again I'll get a barium chromate, yellow BPT. I guess you understood that point. Yeah, in acidic medium it will be like completely soluble. For silver nitrate, again with silver nitrate produce a very nice color that is brownish red precipitate. So I'll be getting a red precipitate of your silver chromate. After getting a red precipitate, again this is soluble in ammonia. We know why. It is soluble in acidic medium. We know why. And with Ag with Cl minus, it will give a precipitate exchange reaction where red PPT becomes white PPT because AgCl has very low Ksp, so the precipitation of AgCl is more favorable as compared to silver chromate. So a silver chromate from reddish precipitate will become white precipitate. It's a very nice reaction to witness, right? Where the live example of uh, precipitate exchange reaction takes place. Okay, a salt which has very low Ksp will displace the anion from the salt which has very high Ksp, and both are precipitate form. So one precipitate is converting into some other precipitate in this. Okay, so this is all about your chromate here, right? We'll be doing further reactions here. We'll be studying further reactions. Lead acetate solution. Lead acetate, we have done lead chromate is yellow PPT. In the YouTube of chromyl chloride, we have made that thing. Lead chromate, again, lead chromate is soluble in your acidic medium. Why? Because dichromate formation takes place. In basic medium is also soluble because in large amount of basic medium it will become PbOH 442 minus. It will become soluble nicely. Getting it? With H2O2, the thing is dichromate, right? H2O2, cold solution in the presence of ether. We have done that CrO4 2 minus in the presence of H plus become dichromate. Dichromate reacts with H2O2 in the presence of cold condition as well as in the presence of ether will produce CrO5, that is chromium pentoxide, which has a very beautiful butterfly type structure. And I do have two peroxy linkage over there with the oxidation state of chromium as +6 in that thing, and it is very unstable. It decomposes to give Cr3 plus again plus oxygen gas. This Cr3 plus is green in color, so you'll get all these changes over here. So I got lead acetate, which is like yellow in color. I got silver chromate, which is red in color. Silver chromate is soluble in ammonia, is soluble in your what is that? Ammonia dichromate in acidic medium, that will become dichromate again. And in Ags with Cl minus it undergo precipitate exchange reaction. So we have done all this stuff right now. Okay, we will move ahead with permanganate solution. Right. Hmm. Permanganate, like understand one thing, permanganate is a stronger oxidizing agent than H2O2. So it undergo reduction, H2O2 undergo oxidation. So H2O2 decolorizes permanganate. Again, it is not the purple color fades away to skin pink. That is nearly colorless. Iron 2 sulfate again permanganate will oxidize iron to iron 3 plus, that is ferrous to ferric. In acidic medium itself get reduced to form Mn2 plus. Getting it? Action of heat. We all know that permanganate on heating and D block you would have done that it produces a manganate thing and a brown precipitated MnO2 with the evolution of oxygen. So this is also a case where a salt is producing direct oxygen. Getting it? So a green uh, heating a potassium manganate sulfur permanganate solution, which is purple. I'll get a green color solution, brown, dark brown, or brown black color precipitate, and oxygen gas comes out. Understood? This is a test for your manganate. So this is the redox reaction test which we have done for chromate, dichromate, and manganate. I guess we'll be doing the analysis of cation. Okay. For anion, we have covered all the ions perspective for JEE as well as for NCRT.